live session. My name is Will Valida, and today we are going to be learning about how to manage end-to-end deployment scenarios by using Bicep and GitHub Actions. Now, today's a very special treat for me personally because I'm joined today by my fellow Aotearoa Azure meetup organizer, Dan Scott Rainsford. Dan, introduce yourself. Can you hear me?
Hi everyone, it's great to be here. Thanks with Will.
Awesome.
And we are really lucky to be joined as well by Nelly, who is our service engineer, who's going to be supporting us as a moderator on the channel. So please say hi to her and post any questions you have in that chat.
Awesome. Cool. So today we are going to be learning about how to manage end-to-end deployment scenarios by using Bicep and GitHub Actions. And the great thing about these Learn Live modules is, live sessions, is you can follow along. You can click that link there. It will take you to the Learn module. So as we're going through the module, feel free to go through it yourselves. And if you have any questions, we do have kind of like a live and interactive question session going. So Nelly will be moderating questions. She'll be there answering some questions that you have. Some of them will be pushed up directly to us so we can actually answer on screen. So please feel free to say hi and ask any questions that you have in the chat. Cool. So Dan, why don't you take us through the learning objectives for today's session?
Sure, Will. Thank you. It'd be great to. So in today's session, we've got 4 things we really want to achieve. We're going to take a look at it and deploying an end-to-end workflow, an application from start to finish, including both the application, any dependent storage and databases from a single workflow. We're also going to take a look at using workflow scripts and workflow actions to perform various deployment steps outside our normal Bicep deployment. We're also going to take a look at workflow artifacts, and these are artifacts that are produced during the running of your workflow that need to be used and consumed by other jobs throughout the workflow. An example might be the database DAC pack that you might push to deploy your schema. And then finally, we're going to look at how your jobs and steps or actions within a workflow can share information throughout the workflow that'll be used by subsequent steps. So that's what we're going to do today. So let's take a look at this a little bit more detail of end-to-end deployments. So you might have seen in earlier Learn Live examples. You might have seen that we've used GitHub Actions to deploy Bicep code to produce infrastructure in Azure. It's a pretty standard methodology. But what we often want to do is try and automate as much of the process of getting our application, our solution running in Azure as possible. And so what we want to do is add as many of those manual tasks that we may be doing manually into our workflow so that we have a repeatable process that we can depend on to get our code into production. So some of the examples might be we need to build our code, or we need to publish the schema of our SQL database or our Postgres or whatever we're running. We might need to configure the host operating system if we're using virtual machines. There's a number of different tasks we might need to run to get our application safely into the hands of users. So in this session, what we're going to do is we're going to take a previous workflow that just deployed Bicep, and we're going to extend, and Will's going to take us through this in a lot of detail. We're going to extend that workflow to add all those additional tasks that we might need to run. So, Will, why don't you take us through the example scenario in a little bit more detail?
Absolutely. So suppose you're responsible for deploying and configuring the Azure infrastructure at a toy company. So like Dan said, we've built our Bicep template to deploy our website, which is going to be hosted on Azure App Service. We've got a SQL database for our products, and we've also got a storage account for hosting images of our products. we've already created a workflow that deploys Azure resources by using our Bicep template. And now what we want to do is kind of extend our workflow to deploy our application, configure the database, and send some seed test data that we need for our test environment to test that our website is actually working. So if we go to the next slide, just to kind of summarize what we're going to be doing, in this module, you'll learn how to extend a deployment workflow that deploys our infrastructure, applications, and databases and data all together. You'll add the build jobs to your workflow that will compile the application and database project, and you'll use workflow artifacts to propagate the deployable files throughout your workflow. We'll be using Bicep outputs from our workflow to integrate our workflow components together, and we'll be updating our deployment jobs to publish our application website and sample data. And if after, just go to the next slide. Oh, one before. Oh, no, you're right. Sorry,
there we
Dan.
go.
Sorry.
My bad.
No, it's
Hey,
okay. I was a little behind.
we're not enough coffee. So yeah, no, before we get really into the meat of this and get you doing some demos, let's actually talk about end-to-end deployments. So one of our goals with DevOps is obviously trying to reduce that time for change and increase that deployment frequency. Those are key DevOps metrics. So the more we can automate, the more we can add into our deployment, our workflow, the faster we can go, the faster and the more safely we can go. So we like to add with GitHub Actions. It supports pretty much anything you can think of. Anything you can do manually is typically going to be something you can do in GitHub Actions. You can add a step or a job to do that task. And so we're going to go through some of those in a little bit more detail. But some examples, as we talked about before, were building and publishing artifacts, containers, images, container images, applications, and running tests, as well as more cases such as pushing reference data, as we'll discussed. But one of the questions we often get asked or have discussions about is, how many workflows should you have? We see one approach is to have a workflow that deploys the Bicep, and then a completely separate workflow managed by a different team that deploys and tests the application code. This is one approach, and we typically, in a little bit more opinionated way, tend to prefer to or recommend to having a single workflow that deploys the Bicep, builds your application, runs your tests, pushes any reference code, configures your database, does everything in one single workflow. There is a lot of good benefits to this. The main ones being that you have a deterministic, repeatable, immutable workflow that that if you run with that set of that commit, you can run that workflow and you will end up with the same result that you did 2 months ago when you ran it. And also, an example of why having multiple workflows can be a problem is that, for example, and Will I'm sure can jump in here with similar experiences. You might have a team that is manages deploying the Bicep for your SQL database. They go and realize the SQL password has been lost or has been potentially needs to be changed for whatever reason. They go and change that in the Bicep, or in the secret in the GitHub Actions. That will then push up. They didn't tell the application team. The application team suddenly has a broken application on their hands, and they'll run around trying to solve it. That is obviously an extreme case, but we do see these sorts of things, and that is where a great, having a single pipeline that does everything can really solve those sorts of problems. Any examples?
Certainly sounds familiar. Yeah, that's a really good, because that does sound familiar. Not naming names. Another good one is with Key Vault. So essentially, I've seen some customers, and I've been involved in some teams that will have kind of like a core infrastructure component. So they'll be looking, say, if you take an example for a platform, and there are teams sitting under that platform, and this team is responsible for the entire platform's infrastructure, and they'll be deploying Key Vault. However, applications sitting within that platform need to have access to those to that Key Vault. However, in Bicep, when you're deploying deploying key vaults, you may create a key vault and not have any existing access policies applied to that key vault. Then the application teams create those access policies in a separate workflow, saying, hey, we need these permissions to key vault. And then when the deployment platform team tries to redeploy that key vault, it wipes away all those access policies if they're not careful, and it just causes issues downstream for those teams. So it's yeah, very familiar pain points you're describing there with SQL.
Right. That's a great point, right? Having a single workflow ensures that no matter the change, no matter if it's a bicep change or a code change or a reference data change, that change goes through the same set of quality gates, the same tests as any other change. So it ensures that no matter who makes the change, you're always getting that high level of quality. So that's why we typically like to focus on having a single workflow, or recommend having a single workflow if possible. There are reasons sometimes you can't, but if possible, that's the way to go. There is a slight one challenge that we often come up against here with having a single workflow, and that is if you deploy your bicep, or if you run your bicep every time your workflow runs, there is obviously a time, it takes a little bit of time for that bicep to complete, and that does increase the amount of time if you waiting for a commit to get into production. Now, for tests, right, where you might want to test as frequently as possible, and changes might be coming thick and fast, that delay in having the bicep code completing can slow your cycle time down, or your developer in a loop. So that can be a little bit of a balance, and there are some ways to mitigate this, but we won't go into too much detail. But it's just a discussion you want to have. How do you do this? How do you deal with this extended time? So, well, let's talk a little bit about control plane and data planes.
Yeah, so many Azure resources provide different planes for access. So we have this idea of the control plane and the data plane. Now, the control plane deploys and configures the resources, whereas the data plane actually enables you to access the resources functionality. So when we create and deploy our bicep files, we're actually interacting with the control plane. Now, in Azure, the control plane is the Azure Resource Manager, and we use the Azure Resource Manager to define the configuration for each of our resources. However, in our workflow, we often need to do more than just interact with the control plane. So, for example, we might need to upload blobs to storage accounts, modify database schemas, make API calls to third-party services, deploy websites to Azure App Service, register DNS. So when you consider kind of the end-to-end workflow, you ordinarily need to deploy your Azure resources and then perform a series of operations against the data planes of those resources. And these, sometimes we refer to these operations as kind of the last mile of the deployment, because you're performing most of the deployment by using the control plane, and then there's be a small amount of configuration that remains for the rest of your workflow. Now, probably something to note if you just go to the next slide. Some resources, and this is can be a bit of a pain point for engineers, don't have a clear division between their control plane and their data plane. And good examples of this are Azure Data Factory and Azure API Management. Now, both services support fully automated deployments using Bicep, but there are some special considerations for each services. We do have more links. We have links to more information about these at the end of the module, which we'll share with you. But it's just something to consider, that there are nuances between different services depending on how you're deploying them.
Gotcha.
Awesome. So when we're performing data plane operations within our workflow, there are three common ways that we can actually do this. We can do this through Resource Manager deployment scripts, workflow scripts, and workflow actions. Now, for those of you who may not know, Resource Manager deployment scripts are defined within our Bicep file. And essentially what they do, they just run Bash or PowerShell scripts, and they can interact with the Azure CLI commands and Azure PowerShell commandlets. You'll create a managed identity for the deployment script to authenticate to Azure, and then Azure will automatically provisions and manages the other resources it needs to create the deployment scripts. Deployment scripts are actually really good when you need to run just a basic script within your deployment process. The disadvantage is they're not that easy. It's not easily to get access to other elements within your workflow. But what you can do is you can run logic within a deployment workflow to kind of overcome this. Now, what GitHub Actions does, it provides kind of this rich ecosystem of actions of common things that you'll need to do. Um, However, there isn't an action for everything that might need your needs. So what you can do is actually run scripts within your workflow file using Bash or PowerShell code. Now, workflow actions and scripts run within the workflow's runner, and you'll often need to authenticate the action or script to the data plane of the service that you're trying to use. And the way that you do this really depends on the service that you're trying to interact with. And the great thing about actions and scripts is they kind of give you flexibility and control. They enable you to access workflow artifacts, which we will learn about soon. In this module particularly, we'll be focusing on workflow actions, but we do have more information about deployment scripts at the end of the module. Cool, awesome.
Cool.
And now let's talk about outputs. So workflows will ordinarily create and configure your Azure resources by deploying a bicep file. And the great thing about outputs is that subsequent parts of the workflow can then interact with the data plane of these resources. And to be able to interact with these resources, actions and steps within our workflow will need information about the resource that was created in Azure. So a good example is, say we've got a bicep file that's deploying a storage account, and you want your workflow to deploy the storage account and then upload some blobs to a blob container in that storage account. The workflow step that will upload the blobs will need to know the name of that storage account to connect to and the name of the container to upload the file to. It's good practice to kind of have the bicep file decide on the names of your Azure resources. So it might use parameters, variables, expressions to create the names of the storage account and blob container. The bicep file can then expose an output that provides each resource name. And later steps in the workflow can actually read the value of that output. So that way your workflow definition doesn't need to hard code any names or other information that might change between environments. Remember, we're managing deployments across our environments or based on rules that are defined in your bicep. And with GitHub Actions, we can actually propagate these values of the outputs using workflow variables. So take an example of the Azure Arm deploy action. This will automatically create variables for each of your bicep deployment outputs. But you can also manually create workflow variables in your scripts. Now, when you need to access variables that were created in another job, you kind of need to publish that variable to make it accessible to the job that needs to read it. So for example, we've got a job that deploys our bicep file. We need to propagate the app service name output to our workflow. You would use the outputs keyword to specify that the name of our app service becomes a workflow variable. And that can be used further along within the deployment. So in your workflow, you can create a dependency on the job that created that variable, and then you refer to it using the name of the published variable. So by using bicep and workflow variables, you can create a workflow that deploys your bicep codes and then performs various actions on the resources as part of your deployment.
Cool. That sounds very handy.
Yeah. So, Dan, let's talk about configuring applications and virtual machines.
Cool. Okay. Yeah. So thanks. Well, obviously, yeah, that output variables does sound like it's a critical feature of an end-to-end workflow. One other thing we often need to talk about is how do we configure any applications or virtual machines that that we've deployed during our bicep. So we're going to take a little bit of a look at building applications. In the next step, we're going to talk about how we configure things like connection strings, for our SQL database, we're going to talk briefly about virtual machine host configuration. But in the meantime, what we're going to do is we're going to go and talk a little bit about building applications with CI/CD. Well,
Yeah, so like you said, many types of apps need to be compiled or built before they can be used. And essentially this build process will take our source code for our application, perform a sequence of activities on it, and then just create a set of deployable files. So the build process will compile our source code into binary files or executables. Now, there are other activities as part of that build process, such as we might be compressing image files that are going to be served to our website users. We might do some linting on our code to verify that it's following good practice, running unit tests to verify that the behavior of individual pieces of our app are working as expected. And you might also perform steps such as digitally signing the files to ensure that they can't be modified. Whatever these series of steps might be, the output of all of this is a deployable artifact. And the artifact is ordinarily saved to the workflow's runner's file system. Now, later parts of that workflow might need to work with the artifact to deploy it to your environments and test it as it progresses through those quality gates you define in your workflow definition. Now, you might have heard the term of continuous integration and continuous deployment, or CI/CD. The build process sits within the continuous integration part of your workflow. Um, Dan, I've heard something a little bit about how artifacts work in GitHub Actions. Could you kind of explain how that works? How long is it stored for? Is
Yeah,
it stored forever, or is there a bit of an expiry on it?
that is a great question. By default, those artifacts are stored for 90 days. You can extend that retention period. But it's important to know that this method of storing artifacts is really to share those artifacts between steps and stages of your jobs. If your organization needs to store those artifacts to become an immutable record of what was deployed to production, there are other ways of doing that. For example, using GitHub packages. So it's also important if you are the output of your workflow is to produce an artifact, perhaps for use by another team, you'd also want to use GitHub packages. It's really important to understand that that artifact that is produced as part of the workflow using this action/upload artifact, that is really just a method of storing that for a temporary period of time and making it available to other steps and stages of the job.
Okay. Oh, cool. Thanks, Dan. So yeah, let's kind of talk about that upload artifact action. So like you said, they aren't artifacts that are generated within our workflow. They're not stored in our Git repository. So we've got our source code and it's derived from our source code, but it's not the source code itself, right? So they don't really belong in a source control repository. So essentially what we need to do is kind of get that artifact from our file system on our workload runner and have a way to kind of store it somewhere. So what workflow artifacts do is provide a way to store files in GitHub Actions and upload it to a particular location. So we'll use the Actions upload artifact workflow to tell GitHub Actions, take this file or folder from our file system and upload it as a workflow artifact. So there we'll provide our action with a name. We'll also specify a path to where our compiled code's going to be retrieved from the file system. Each artifact will have a name, which we'll specify with the name property. And then we'll use that name of our artifact to refer to it later throughout our workflow. So subsequent workflow jobs can download the artifact so they can work with it. So for example, deploying that website to the server that hosts it. And I think we've got a good example of deploying it to app service, but before we get onto that, yeah, here's just like a nice visual kind of visual representation of how that would work. So within our build job, we're compiling our code, we're running our unit tests, and here we're publishing our artifact to a particular location as a workflow artifact. So in our subsequent deploy job, we're downloading it so we can actually use that artifact to deploy it to Azure App Service.
Cool. Well, so let's take a little bit of a look at that actual deploy job. So there's lots and lots of different actions available for us to deploy artifacts, but because we're going to be using and deploying to an Azure App Service, we're going to use the web apps deploy action, which is an action available in GitHub Actions. So this action basically takes that artifact that was produced in an earlier step or an earlier job in this case, and it that artifact is downloaded onto the runner, and then we're going to simply pass the name of our app service and the location of that artifact and push it up to our app service plan. And of course, that app service will have been deployed via a Bicep file in an earlier job or an earlier step of our workflow. So that also brings into the discussion those outputs that Will was talking about earlier, where we needed to output the name of the app service. So this is going to be a really handy feature that we're going to be dealing with there. So, but let's take a little bit of a look in more detail at how this process of getting that artifact up into the app service works. Now, this is also brings the discussion of control planes versus data planes, because this action actually uses both. It uses the control plane and the data plane to get that artifact up into app service. So what it actually does during this process is it uses your workload identity to retrieve a token from Azure AD to allow your workflow to talk to the Azure control plane. And it does that so that it can get the deployment credentials from the app service. And then once it's got, and it does that through the control plane, of course. So once it's got that credential, it can then push that artifact up through the data plane to deploy your website, because that web deploy website is actually done through the data plane of the service. So that's a great example of how that's actually done in an action using both control plane and data planes. So I mentioned earlier we were going to talk a little bit about other services that we might need to deploy to. Now, app service is obviously one of many places you could be hosting your built application. Virtual machines is another good example where you might need to use something like SSH or PowerShell remoting to get into that virtual machine and push your code. You could use Azure VM extensions to do that as well, a script extension. We also possibly need to configure that virtual machine. So you might need to use a configuration management service or system like Chef, Puppet, Ansible, and of course PowerShell DSC. For container-based workloads like Kubernetes and AKS container instances or Azure Container Apps, you might need to publish a container image, push that out to a registry, and then update the configuration of your Kubernetes cluster to retrieve that, to get that new version of your artifact, your image. So, Will, obviously another part of this is quality control, testing in your pipeline. Do you want to talk a little bit about testing your workflow?
Definitely, because in previous modules, we've learned about the importance of running automated tests for our workflow. So when we're deploying our applications, it's good practice and a good idea for the workflow to run some tests that will invoke the application's code. And the idea around this, we're not doing it, just to pat ourselves on the back saying, oh, we're testing our code, it's great. We're actually doing this to reduce the risk that our application or any deployment errors might cause downtime for our users. So we're doing it in a way that makes sure that our code is of high quality and it's not going to cause any downtime for our users. Now, in more advanced scenarios, we might perform a set of test cases against our application. So this could involve invoking APIs or submitting and monitoring a synthetic transaction to kind of do that end-to-end process rather than just testing a specific unit of our code. We might do more sophisticated tests that say, okay, does the system work as expected end to end? Many applications also implement health check endpoints. So when a health check endpoint receives a request, what it will do, it will perform a series of checks against the website or application, ensuring that all our databases are okay, that network services are reachable from the application's environment. And the response that the site returns indicates whether the app is healthy or not. Now, developers can write and customize their own health checks to suit the application's requirements. Some health checks are easy to configure. Just click a checkbox or configure a Boolean in a Bicep file out of the box. But the idea is if your app has a health check endpoint, it often makes sense to monitor it from your workflow after the deployment finishes. So you might have an extra step to perform those health checks to make sure, yes, the deployment was successful. Is everything still running? Because that's it's always a good
we
good thing to know.
yeah, it's critical, right? And especially we like to think, DevOps is about going faster, but I think it's about going faster without the car wheels on your car falling off, right? So those automating those tests are so important, and there is so much you can automate, right? We so often see people automating security tests, operational verification tests, as you talked about, and also it's good to think about not just happy path tests, but what we call sad path tests.
Yes.
If you want to block, if you want to make sure your application's only running on HTTPS with TLS 1.2, make sure you're verifying that your application is not using those things. So we often gloss over those sad path tests, which are very useful.
It's always good to go the sad path tests, especially when DevOps. What would DevOps be without the sad paths?
Yeah, exactly. We can't all go down the happy path. So
No.
we're about to get onto some really meaty demonstrations, but just before we get onto those, let's take a look at the end-to-end workflow. Well, what does that look like?
So in this exercise coming up, we're going to actually update our deployment workflow to add new jobs, to build our website's application and deploy it to multiple different environments. So as part of our build process, we're going to want to build our application, make sure it compiles any tests that we're running, make sure they're passing, and do any linting to make sure our coding is followed best practices. Then we're going to be deploying to our test environment. So we're going to validate that our bicep file is a valid bicep file. We'll deploy our bicep template to our test environment. We'll be deploying the website and doing some smoke testing to make sure everything's okay. And then the idea is once everything's fine in our test environment, we're going to be deploying, performing the same tests within our production environment, or steps, sorry, in our production environment. So with that in mind, what we're going to do, if we switch to my screen, is that coming through okay? Dan?
Looks like it, yes. Sorry, I was switching my screen to see
Awesome,
yours. Yep,
fantastic. So
looking good.
to start off, we're going to set up our environment. So here, what we've got within this Learn module, we've got kind of this pre-built application ready for you to kind of start building out your workflow. So here, MS Docs, this MS Learn manage end-to-end deployments using Bicep GitHub Actions. This repo is available within the Learn module. And what we want to do is we want to use this as a template. So I'm going to click on this Use this template and create a new repository. And here, what I'm essentially doing is using this to create a new repository within my GitHub account. I'm going to name this repository Toy Website End-to-End. And I'm going to make this a public repository. Now, there might be some cases where you use private repositories, but in this module, we're going to be working with features that only work with public repositories and GitHub Enterprise accounts. But we'll use public for now. And I'm going to create that repository from the template. And then what I want to do, once that's generated, I'm going to clone this onto my local machine so we can start working with it. So to do that, I'm going to click on code, and I'm going to copy and paste this HTTPS link here. So I'm going to do that. And now I'm going to switch to my Windows terminal. I'm going to be running PowerShell throughout this demo. So what I want to do is not capitalize it, but go git clone. I'm going to go shift insert to paste the URL link. And then I'm just going to clone that. I'm going to go into that directory. So cd toy website end-to-end. And here I am in the repository. Now, I've already signed into Azure, but if you're in PowerShell, to do that, if you've got the AZ PowerShell module installed, it will just be a case of typing connect AZ account, and this will prompt you to sign in. But since I've already signed in, we're now going to create our two workload identities. Now, we covered workload identities in a previous module, but just to recap, they're a feature of Azure AD. And Azure AD will have this concept of an application which represents a system, piece of software, process, or other non-human agent. And we can think of our deployment workflow as an application. So when we create an application and tell Azure AD about it, we'll be creating an object called an application registration. And this will represent the application in Azure AD. And this registration can have federated credentials associated with it. And what's great about federated credentials is they don't require you to store any secrets. But instead, what we'll do is we'll enable our Azure AD application to be used with a supported service like GitHub. So what I want to do is just copy and paste. I want to set my GitHub organization name. So this will be your username in GitHub. So that's Will the Leader. And then I'm going to copy and paste the GitHub repository name, also the name of the repository that we've just cloned. So it'd be toy website end-to-end. Cool. So now I'm in a position to create my workflow identity for my test environment and associate it with my GitHub repository. So I'll create a new test application registration using new Azure AD application. I'm going to give it a display name of toy website end-to-end test. And then I'm going to create two Azure AD federated credentials. So one is going to be configured for my test environment. So I'll paste that, but before we paste it, so I'm creating a new federated credential, giving it the name toy-to-toy end test, using the application object ID from our application registration that we've created earlier, issuing it the ability to get tokens from GitHub, using Azure AD Token Exchange as the audience, and then my subject will be the repo and the repository, the repo that I've created, and my test environment that we'll create later on. So I'm going to give that a run, and that's created my federated credential. And then I'll just create another one for the actual repository itself. So the first first federated credential is for the environment, and then the second one is for the actual GitHub repository. Let me get some more real estate here. And we're going to do the same thing for our production environment as well. So here, just going to copy and paste for time, going to create an application registration for my production environment, create a federated credential for that production environment. And then I'm going to create a new federated credential for my repository to interact with that production environment as well. Cool, so that's all set up and ready to go. So now what we need to do, we've got our workload identities. We need to create two resource groups in Azure and actually grant the workload identities access to those resource groups. And for this one, we're going to be giving those workload identities the contributor role. So first up, we're going to create a new resource group called toy website test. So I'm using that PowerShell command, new AZ resource group, giving it the name toy website test. I'm just going to be deploying it in West US free for now. And then we want to create a new service principal. And for this, I'm going to use the application of our ID of our test application. And then I'm going to grant it a new role assignment. So I'm going to give it that contributor access to this service principal that we've just created. It's just thinking about it, and there we go. It's been created. Always nothing to wake you up like a delayed response from a command line interface.
We've all been there.
It's that lump you get in the throat, right, and your heart rate starts increasing. But
that's
now
the coffee.
That's the coffee. Oh, I haven't had coffee this morning, so maybe that's a good thing that I'm doing this. I'll be wide awake by the end of it.
Yeah.
And we're going to repeat the same processes for our production environment as well. So here I'm creating the service principal, and then I'm also going to create my role assignment as well. So here you can see the application ID is the production application registration, the app ID of that app registration in production, not our test one. So just be careful when you're doing this. Make sure that you're creating the right granting the right identities, the right permissions for your test and production environments. Cool. So now that we've set all that up, we need to create some GitHub secrets within our GitHub account, GitHub repository, sorry, so we can actually use this within our workflow. So here, I'm just going to copy and paste this, but what I need is the client ID for my test and production environment, my tenant ID and subscription ID. So what I'm going to do is I will just bring that back down. And I'm going to copy and paste that by creating secrets within my repository. So if you go to, I'll actually scroll in a little bit, make it a little bit easier for you all to see. Go into settings, then underneath secrets security, we go to secrets and variables, and here we click actions. And here, secrets are just environment variables that are encrypted. So we can actually use them throughout our workflow within GitHub Actions. And so to do this, we create a new repository secret. And I'm going to start by creating my secret for the client ID in our production environment. So that output that we've gotten from running that PowerShell command, we are just going to be copying and pasting that. So the name of it will be this capitalized Azure Client ID production, and then the secret will be the GUID itself. And I'm just going to kind of copy and repeat the process, sorry, for my test environment.
Gotcha.
And then,
and even though these are secrets, right? These aren't actually the credentials themselves, which means we get that added security from using workload identity. We're not actually putting secrets into or credentials into GitHub Actions.
yes. So I've set up all of my secrets. So I've got my client ID for production, I've got my client ID for my test environment, and my subscription ID and tenant ID that will which will allow the workload identity to authenticate to Azure. So
awesome.
Now that we've set up our secrets, we've got to set up our environments. And for this, we're going to work with two environments. So to do that, we go into environments and then add a new environment. So I've got one for my test environment. And we don't need to configure any protection rules. Traditionally, you might add required reviewers or wait a timer before allowing the deployment to proceed. These are good quality gates that you should be implementing. For the purpose of this module, we're going to just ignore that. But when you're working in your environments, do enforce these protection rules just to provide a little bit of security around your deployments to each environment. So we've set up our environment, we've set up our secrets for our GitHub Actions. So now we are ready to deploy our web application. So what I'm going to do is going to go back into the command line and to my PowerShell prompt. I'm going to type code. Why is it down there? That's funny. And then dot.
We like a challenge. We like to keep things mixed up, right?
Absolutely. Oh, that's fun. So what that command essentially does, it will open up that folder directory in Visual Studio Code, which is really, really handy. So what we want to do now is we want to add a new job definition that contains the steps required to build our website application. So what I'm going to do is I'm just going to open this GitHub Workflows folder. And it looks like we need to add a new workflow for our build step. So build.yaml. I'm going to let that file create. And since we're working with a .NET application, so if I go back into the workflow while that's thinking about creating the file, here what we've just got a .NET Core 3.1 application. So we need to build our application that will build our .NET application. So if we go back into Visual Studio Code, I'm just going to copy and paste this build workflow. So here, if you're a .NET developer, this will be very familiar to you. If not, what we're doing is we are running this job on a Ubuntu workflow runner. We're going to be installing .NET Core. So this job can use .NET Core 3.1. We'll build our website using this .NET Publish command. We'll zip it up into this working directory, and then we're going to upload the website as a workflow artifact using that upload artifact that we talked about a little bit earlier.
Gotcha. So
So
that
pass.
artifact will now be available to other jobs, right? So
Yes, yeah, that's the idea.
awesome.
So
Awesome.
this working directory here is essentially the directory where we're going to publish our zip file to. And then
Cool.
this path here is like, okay, there's the zip file. I want you to upload that as a workflow artifact.
Nice.
Awesome. So now what we need to do, we need to add this build job to our workflow file. So if I go into my workflow YAML file, essentially what we need to do here is we need to add the job to the we need to add the build job to this jobs list here. So before we lint our Bicep code and deploy to our test environment and production environments, we're going to build our application. And I like this approach because essentially if you're running unit tests as part of your build process, you can see if unit tests fail right away rather than waiting for your environment to deploy. And that can take a long time. So it's good to catch failures early, essentially.
So you're using GitHub Actions templates here, right?
Yes, yeah, that's the idea. So this build job here is using that template that we've defined. So this build.yaml file, we're essentially saying, okay, this is the kind of templated process to build a .NET, to build our website. And then within our workflow, it will refer to the jobs being performed in this in this actions workflow file here. So here we're just, rather than having all of these steps defined within our workflow file, we're just essentially referencing a template, which is a really
Yep.
nice way of like kind of like tidying up your workflow files and also sharing those workflows between different different pipelines. So here we're just using it within one example, but if you're in an organization and there's kind of like a standardized approach for deploying your applications, this is a really nice way of templating that out so other teams can use that template for their own applications.
That's really cool because I notice you're using the deploy YAML, the deploy workflow, both for dev and for test and production, which of course
Yeah,
is saving you a lot of repeated code, right?
yeah. So the only thing that really changes are the secrets that we're using. So we're using secrets relevant to the test environment and also the kind of parameters for that test environment as well. So like you said, rather than having all of this jobs in this deploy file repeated in one workflow file, we've actually just tidied it up in a way that we can template that and standardize it across multiple environments, which is really neat.
Very cool.
Now, we do need to make one change to this deployed test. So currently this needs parameter. It's just saying, okay, we need the lint job to be successful, but we want to change that to take a dependency on both build and lint. So essentially what we're saying here is that build and lint need to be successful before we deploy to our test environment. So it's just a nice way of kind of creating those dependencies to make sure that we're not running jobs too early. And then for our production environment, we want to add these as well. There are a couple of ways of doing this. So we can actually use this array to pass in jobs. But if we've got multiple jobs that a particular job needs to depend on, we can also write it like this. Hopefully the YAML indentation doesn't hurt me. It has slightly, but that's okay. So here we're just passing through multiple jobs, so lint, build, deploy, test, all as this as a list, and here we're passing it through as an array. So
Gotcha.
there's a couple of ways you could do this, which is quite neat.
And of course, we wouldn't want to deploy to production if our deploy to test failed, right?
No, definitely not. It's not a good idea. Cool. So now as part of this deployment, we're going to be running smoke tests. So what the website developers have done in our scenario is they've added a health endpoint to the website. And like we mentioned earlier, this is going to check that the website is online and it can reach the database. So what we need to do is add a smoke test to kind of invoke that health check from our deployment workflow. So
Cool.
under deploy, we have this website.test.powershell PS1 file. And all we need to do is just add this test. So I'll just copy and paste that in. Not now. So essentially what we've done here, we've added it as saying, okay, it should return a successful response from the health check endpoint. So we're invoking a request on our host name and that health endpoint here. And we want to write the content back. And we're expecting the response code to be 200 because the website should be configured and it should be healthy. That's the idea.
Awesome. And that's PowerShell Pester, isn't it?
Yes, I believe
Yeah.
so. Now,
Yes.
you have a little bit more experience in Pester than I do, so do you want to quickly explain what that is for the folks?
Yeah, PowerShell Pester it's a PowerShell module, freely available. It actually comes on most Windows machines, so you probably already got access to it. Allows you to write standard tests using PowerShell in a very descriptive language. It's great for doing these sorts of infrastructure and operational verification tests. And you would have noticed or you may have noticed in there was actually a sad path test that verified HTTP was not working, and that is great, right? We want those sorts of tests. We want to know
Absolutely.
that we are secure, and this is a perfect way to do that.
Now, to actually make this host name available, what we need to do, um, the publish step requires the name of our app service app name. So what we're going to do is we're just going to add an output in our main.bicep file. So right down at the bottom, I've got an output for my host name. And so now I've got an output for the name of my app service as well. Cool. And then once we have this output, we can actually update our deployment job to propagate the output. So here in our deploy file, if I go down into my deploy step, there it is. So I've got my output for app service host name. So now I just need to do it. I need to add my app service app name as an output as well to that deployment step. Just fix that indentation. Awesome. Now below our deploy job, we need to add a job to deploy the website. So here, all we're doing in this deploy job is deploying our Bicep template. So we actually need to perform those operations against the data plane to deploy our website. So underneath the deploy step and above this smoke test step, I'm just going to copy and paste this deploy website job, fix the indentation. And so here we're saying that we need the deploy job to be successful. We're running this on Ubuntu. We're putting an input of our environment type in as an input for the environment. Signing into Azure using that workload identity, and then we're deploying our website using web apps deploy using the publish zip file that we've defined earlier within our build job. Cool. So looking at that quickly, top to bottom, Dan, does everything look okay to you? Is
Looks
there anything?
pretty good to me. Looks pretty good to me. One mention. What's the permissions there?
So these are the permissions that we need for GitHub Actions to actually deploy stuff to our Azure environment or deploy our resources. So these are the permissions that our workload identity will need
Right.
to deploy to Azure. Have I got these in the right place? So I've
You
got them
have
in my workflow.
indeed. You have indeed. So it's an important thing to remember here. Although your workflow is actually going to be interacting with Azure from the deploy template, you will still want those permissions in the parent, in the workflow that is actually being run. So you will see those permissions in this workflow, not in the deploy or .yaml.
Nice. Awesome. Cool. So now that everything looks okay, we're going to actually um, push those changes up into GitHub. So to do that, I always run git status before I add anything to my git commit git history,
Mm.
just to see what I'm actually committing. Those looks like all the files that I'm committed. We're not going to
Looks
get any
good.
nasty surprises. So I'm just going to type in git add, then that dot to add everything to the commit history. You can specify or add the particular files as well, but we're just going to add everything. And then I'm going to commit my changes, build and deploy website app. And then I'm going to push that up into my GitHub repository. Now, if this is your first time pushing to a GitHub repository, you might be prompted to sign in. There are instructions in the Learn module how to do that, but for now, I've already authenticated, so that should be fine on my end. So
Nice.
once everything's pushed up, if I go into not that, there we go. So now what we need to do is actually see our actions being run. So we had an initial, when you use the template, there's an initial commit created. That's because we haven't set up our our federated identity, so that's going to fail. So don't worry about seeing if you see that. But here, what we should do is start to see our workflow in action. So here are the build steps and the lint steps that we've defined earlier. So we've said that the deploying to our test environment, so the validating our Bicep template, that will need these two to be successful before that starts. That's happened. And that's going to validate and deploy to our environment. How are we doing on time, Dan? Because watching,
We've got
it's
another
always a bit tense
33,
watching.
33 minutes, so we'll push it along because we know we've got some very large demos to come. So yeah, it might be worth just jumping.
Do you want to share? Are you able to share your kind of output
Yes, I think I am.
to see what's going on?
Yeah, let me just drag mine down here. And this is a demo I have done earlier.
This is how you know we're
Basically,
doing it
if
live.
you so doing it live, I did this 3 days ago, but this is the output you will see. So, oopsie, down there. Hopefully we're sharing my screen.
Yes.
So we've been, so here, as you can see, those checkboxes haven't shown up because we did find some issues earlier in the day that a few days ago, we found some issues. So this is actually what it will look like. As you can see here, I'm zooming in. But can you just talk a little bit, before we move on, just talk a little bit about the actions/download artifact step. So obviously we've talked about uploading an action, but how does the artifact get onto the runners? Say we've got the artifact is produced by one job, but we need those artifacts down onto the other, the runner on the next job. If we can switch back to Will's screen as well.
Oh, I'm actually no. So is that coming through?
That is coming through, yeah.
So I'll open up Visual Studio Code, where
in the deploy, we will have had a reference to. Now I'm just in our deploy website, where actually you can see users actions download artifact. Now what that is going to do by default is download any artifacts that we have produced in previous jobs or dependent jobs onto the runner, and it's going to put it into the same folder structure that we actually uploaded. So there's /artifact/ whatever the path was. So if you need to use those artifacts in one of your jobs or one of the steps within your jobs, you need to specify that action. If you don't, the artifacts are not going to be available.
No. And you can actually name particular artifacts as well. So here we're just using the GitHub action to download the artifact, but you can also specify a name of an artifact and also the path to where that artifact is being stored. So you do have those options as well.
Gotcha. And it would be a good practice to only download the artifacts to jobs that you need them, because there is
Yes,
it takes a little bit of time to download those artifacts, and if you don't need them, don't download them.
exactly.
Just reading the chat. Cool. So that's getting our environment set up. So I'm just going to flip back to the slides here so we can move on to the next step. During this process, we actually did we went through setting up the environment, cloning the template. We went through creating a workload identity. We produced the resource groups. We prepared the GitHub secrets and the environment in GitHub. We got everything set up to really make our workflow, end-to-end workflow. The thing we did observe, of course, is that although our workflow is set up, we haven't completed it yet, which is what Will is now going to do. He's going to go and take us through deploying a web application. So take it away, Will.
That was the last demo, so we've kind of skipped ahead a little bit, but that's okay, because we've set up
Yeah.
our environment and then we've used that.
Yes. Yep.
Yeah. So I think now it would be probably a good time, since we know the smoke test fails, because there's no storage or database being configured. So as you can see there in our smoke test, that has failed. So it's probably a good time to start talking about how we can actually configure storage and databases within our workflow. So I'll let you kind of get back to the slides.
So there we go. So what are we going to do in this next demo? Well,
Oh, Dan, can you hear me? We've done the web application demo. So if you skip
oh,
forward
you've done.
a couple of slides,
My bad. Okay, sorry about that.
There we go. It's all good, man.
Oh, good. So hey, this is what it's all about when you're doing it live, right?
Yeah.
So as you said, we've got the smoke test, we've got our end-to-end pipeline, we've deployed we've got everything ready, but now we are going to add some additional steps in our workflow. We're going to go and create a database inside our deployment, and we're going to configure the connection to that database and make it available to our web app. And we're going to also look at how to create a storage account and then upload some reference data for tests, so we can run some tests. Right, we might not need that data in production, but we're going to look at how you might do that in a conditional way as part of your test stage. So as we mentioned, we're going to add some data. So many databases have schemas. So these represent the structure of the data contained in the database. So it's often a good practice to deploy that schema from within your workflow. That way it's ready for your application to use. Your application doesn't have to do it, and you can execute tests on it. You might also want to not only apply the database schema, but you might also want to push some data into your database. For example, publish a DAC pack. For this process, we are going to use a built-in action. So there's an action called Azure/SQL action, which allows us to connect to any SQL database or any Azure SQL database, and then run a SQL script or push a DAC pack up to it. We can authenticate to that database in a couple of ways. We can authenticate using a username and password, but as of the version 2 of this action, you can actually authenticate using Azure AD and that workflow identity. So this can be a great practice, but we're going to use the login and password because that's nice and straightforward in this case. Some other data and storage services don't need to be configured by the data plane API. For example, when you're working with Cosmos DB, you can store data in a container. You configure your containers by using the control plane right from within your Bicep file. So this also refers back to what Will was talking about with data plane and control plane. Some resources can be configured with either, but in our case, we were using the control plane. Similarly, you can deploy and manage most aspects of storage blob containers within Bicep too. But in the next exercise, we're going to show you how to create a blob container from within Bicep. So as I mentioned, it's pretty common for you need, in your test environment at least, to push some data into your SQL database or whatever database you're using so that you can run tests against it. So your application actually behaves. So we are going to also demonstrate the use of another um, action to connect to the database and run a DAC pack or deploy a DAC pack to push some data into it, which is really just a SQL script that adds that data. So I'm going to quickly mention the idempotence. So say we've got a workflow that's going to deploy the schema of our database into our SQL data as part of the test stage, and it's also going to put some reference data into that database. If our test environment persists between runs, perhaps because it takes a little while to deploy that test environment, we don't want to have our data or our test data build up. If you just had a SQL script that just did a bunch of inserts to insert that test data, the data is likely to build up and build up and build up. So what we want to do is look at idempotency. So this is where that describes infrastructure that if we deploy or run that script or run that code over and over, we will always end up with the same result. We won't, if the data is already there, it won't re-add that data. So what you want to be a little bit careful of is ensure that your any kind of data injection or reference data that you're loading is only added if it doesn't exist. And that's called idempotent. So it's important to look at. So a little bit more detail on the workflow itself. So in this workflow, we are going to add a new stage to the build that produces a DAC pack. Now, a DAC pack is really just a fancy word saying it's a bunch of SQL scripts that are going to get run or deployed to that database. In our case, it is a very simple SQL script. And we're going to produce that DAC pack as an artifact. We're going to use that actions upload artifact action. We're going to make that a permanent artifact that goes along with this build. And then we're going to use that in a later job with a different GitHub action that will connect to our database and push that DAC pack. So Will, do you want to take us through a little bit of the network security side of this?
Why not? I've always had fun with network security,
We
so why
all
not?
love network security.
Why not vent? Use this platform to vent about net. No,
Yeah,
it's
go for it.
sometimes when we're working within our Azure environments, we're going to have network restrictions applied to our Azure resources. And these restrictions can enforce rules about requests made to the data plane of our resources. So, for example, the database server that we deploy can only be accessible from a specified list of IP ranges, or the storage account is only accessible from resources that are deployed inside a virtual network. Network restrictions are common within databases because it might seem like there's no need for anything on the internet to connect to that server. However, with network restrictions, it can make life a little bit tricky when it comes to deploying our resources and kind of using our deployment workflows to interact with our resources data plane. When you use a GitHub hosted runner, so if you're coming from a DevOps background, it's very similar. Azure DevOps background, I should say. There's an idea of Microsoft hosted agents and self-hosted build agents. With GitHub Actions, there are GitHub hosted runners and then self-hosted runners. With GitHub hosted runners, its IP address isn't easily known in advance, and it might be assigned from like a large range of IP addresses. Additionally, GitHub hosted runners can't be connected to your own virtual networks. There are some actions that help you perform data plane operations that can work around these issues. So, for example, that Azure SQL action. In other situations, it's not possible to create exceptions like this. So, if we just go to the next slide, just trying to visualize this this scenario. So here we're interacting with the data plane to publish our DAC pack file to execute a script. In situations where we have network requirements and restrictions, Consider using a self-hosted runner. And essentially what self-hosted runners are in GitHub, they run on virtual machines or other compute resources that you control. So rather than using a GitHub hosted runner where it's hosted by GitHub, we don't know what the IP address is, and it might be assigned from a large pool of IP addresses, we have some ability to configure our own self-hosted runners on compute resources that we control. And then we can configure this runner to however we need to use it. It uses a known IP address because it's in our control, or it can be connected to our own virtual network. We don't discuss self-hosted runners too much in this module. There is more information that we'll provide to you in the summary at the end of the module, but it is good to keep that in the back of your mind if you have network restrictions on your Azure resources. Cool. So what are we going to be doing in the next exercise, Dan?
So in the next exercise, we're going to take that previous pipeline that you've just set up and we're going to add some additional steps. We're going to add some steps for deploying our seed database, or deploying the schema for our database, and then deploying the seed data to it. We're then going to seed our storage account. So we're going to copy some images in for our toy website so that we can actually show that our application is up. And this point also, because we've got all these other things deployed, our smoke tests will pass. And then of course, in production, we're not going to deploy seed data, but we are going to make sure that our schema is there, and we are going to make sure our smoke test is passed. So Will, why don't you take us through that process?
Awesome. So the first thing we're going to need to do is add a blob container to our Azure storage account. So we've already defined our storage account. I'll just get rid of the terminal here. Where is it? So here's our storage account. So now what we need to do is add a storage container for those images to be hosted. So I've got this variable here that I'm going to copy and paste. And this is going to create or define a blob container name called toy images. So once we've got the name of our blob container, we can actually update our storage account Bicep resource to create that container. So I'm just going to copy and paste. This is going to be a child resource of our storage account. So here it is. So here's the name of our container that we've defined earlier in our variable, and we're saying that this has got blob public access. This is going to be a blob container. Now we need a way for our app to be able to connect to this storage account and to the blob container name. So here within my Azure App resource, I've got a bunch of app settings. So what we need to do is we need to add our storage account name, the endpoint of our storage account, and also the container name as app settings to our app service. So I'll copy and paste that. And there we go. We've got our storage account name here, our blob endpoint, and our container name all as app settings within our app service. And then finally, what we need to do is we need to add new outputs to expose the names of the storage account and blob container. So what I'm going to do is just copy and paste these underneath my app service name and host name. So here I've got an output for both my storage account name using the name property of my storage account resource, and then the blob container name here. So here you've got this kind of cool colon notation here. So we're accessing the blob container name that's living inside our blob service, which is living inside our storage account. So that's updating the Bicep file. So what I want to do is I just want to save that to my commit history. So what I'll do, I'll actually not press enter a bunch of times. And I'm just going to add those changes to my to Git, or stage those. So add storage container, but I'm not going to push it. So we're just going to stage the changes for now. Cool, so we've got our storage account. So now if I go back into Visual Studio Code, we need to add an Azure SQL logical server and database. So at the moment, our Bicep template isn't deploying a SQL database. So what I need to do is I need to add 2 new parameters for my login and password. Now you can and should use managed identities to connect to Azure SQL, but in this scenario, we're just going to use the login and password, and we're going to provide that as parameters to our Bicep template. Before we address these, we're going to add 2 variables that define the resource names. So this is going to be the name of our SQL server and the name of the database that's going to be deployed in that SQL server. And then this is a massive no-no, but we're going to do it just for the purposes of this scenario. I'm going to add the connection string as a variable within my Bicep template. Now, this isn't good practice in production. I can't emphasize that more enough. It's better to use managed identities to access the database, then grant that managed identity the minimum permissions needed by the application. And we've provided more information in the resources to help you get going with that. But for now, we're just going to slap ourselves on the wrist and say this is how we're going to do it. And now what we need to do is add our resources for our SQL server. So at the end of our Bicep file, but above our outputs, just going to copy and paste the resources required. So here I'm creating my SQL Server resource and defining the login and the login password as our properties. Here I'm adding a firewall rule to allow all Azure services to access my SQL Server. So this is just a firewall rule that we're adding. So other services like our app service can interact with the database. And then I'm creating the database within the SQL Server. So here we're providing the database name, and then the SKU will be dependent on the environment that we are deploying to. Now here we're using a configuration map to define the SKUs for each component based on our environment type. So here we're going to be using the same SKU for production and test. So we're just using the standard tier, but for your scenario, you might use different SKUs depending on which environment that you're going to be deploying to. And then finally, I believe finally, in this Bicep file, we need to add the app setting to our app service for the database connection string. So all that really is just adding another name value object. So using the value of our SQL database connection string variable will be set to this app setting SQL database connection string. Oh, one more thing. We need to add outputs for our SQL Server resources. So here we're adding outputs for our fully qualified domain name for our SQL Server, and then the name of the SQL database as well. So those are all the changes that we need to make within our Bicep file. So now, what our website developers have done, they've prepared a database project that will deploy and configure your website database table. So what we need to do is we need to update our build workflow file to build the database project into a DACPack file and upload it as a workflow artifact. So here in our build workflow file, I'm going to add another step after building our application. We're going to add a job to build the database project. So here we are using a Windows runner. So this is a difference just to point out. So for building application, we're using Ubuntu, but for here we're using Windows. Now, to the best of my knowledge, Visual Studio database projects must be built on the Windows operating system. So if you're following along, make sure that you're using a Windows runner to run this job. And once we've done that, we're going to save changes to our file. So now what we need to do, we'll go back into GitHub, make sure. So see this same failure that Dan showed earlier has occurred in my pipeline. So that's kind of good and bad. Good that we know that the pipeline's working as expected, but bad is we need to fix that. But now we need to define the secrets to store our Azure SQL's logical server's administrative password for each environment. So what I'm going to do is go back into settings. Underneath secrets and variables, just going to click on the drop down and click actions. Now for this, we're going to create 2 new repository secrets. So for my test environment, I'm going to create a new secret name, SQL Server Administration login password for test. I'm going to use this ultra secure password that no one's ever going to hack, and then add that as a secret. I love the exclamation mark, just doing the
Yeah.
heavy lifting there.
Yep. Yep.
And
Satisfy the
then
minimum requirements.
absolutely. Um, and then we're going to add one for our production environment as well. And just because we want it to be really secure for our production environment, we're going to increment the numbers.
Oh,
Oh, yeah.
sorry to all our security people out there.
Oh, no one will ever hack that. I don't know what you're
Mm.
worried about.
Of course, we could have used the SQL Azure AD integration, right? That would
Yes.
eliminate that problem.
And avoid all of that drama and those weird
Love it.
conversations.
Love it.
Cool.
Now we've
So
got
now that
11 minutes left, by the way. 9 minutes left. Well,
awesome. I will try and pick up the pace. So what we need to do now in our deploy file is provide some inputs. So for inputs will be our administrator login, and for our secrets will be our password. So save changes to the file. And then in our workflow file, we'll need to add those to our different environments. So for our test environment, we're adding a new input here for our administrator login, and then we'll use the secret that we've just created for our test environment here. And we'll do the same for our production as well. So copy and paste. Save that. And now we need to add parameter values and outputs. So if I go back into my deploy workflow file, I'm going to add these two parameters for the login and password into the validate step. That looks good. Make sure that's okay. In the what if as well. There it is. And then in the deploy step, we also need to add those two parameters down here. Make sure that looks good. Yeah, yes, it does. And then in the deploy definition, we also need to add the outputs that we've created for our storage account and our SQL database as well. So the outputs that we've defined in our Bicep file, we also need to put that in the outputs here within our deploy step. So now we've added the database and, well, we need to add the database and data seed jobs. So under deploy website, but above the smoke test, we're going to deploy our website. So again, it's just going to be deploying that DAC pack to our database. And then we're going to seed our database. So before we run any smoke tests, we need to make sure that there is data there. I'll just fix the indentation on that. And then once we've seeded our database, we also need to seed the storage account as well. Awesome. And then finally in our smoke test job, we need to update all our job dependencies to make sure that they run after all of those jobs have been successfully completed.
love it.
Fantastic. So I'm going to assume I've done everything right. If not, GitHub will complain at me, which is kind of cool. And I'll go back into my command prompt, PowerShell prompt, sorry. And I'm going to just add those changes. And I'm going to push those up. So once that's pushed up, that should kick off the GitHub action. So click into actions.
Nice.
And
Here it
that's
goes.
going to kick off the job. Now, Here's one we've kind of prepared earlier. Dan, let me know when you're sharing your screen so we can show the good
Let
folks.
me flip across. Yeah, if you can switch to my screen. As you can see, this actually would take a few minutes because we're deploying a bunch of resources, or we'll be deploying a bunch of resources. So this is what the final workflow looks like. I'm gonna zoom in a little bit there. And as you can see, we've now added a few additional steps to, or jobs to our deploy. We're deploying our database, we're deploying our website and our storage, and setting our storage account. Notice we're actually doing these in parallel, which is one of the cool things, as we'll specify those dependencies between the jobs that allowed GitHub Actions to run some of this stuff in parallel so that we could do it all together and speed the process up. We've also seeded the database, but of course that's got to happen after we've deployed the database schema, and then the smoke test here has passed. Again, the deploy to production stage only occurred after the smoke test passed. And one other thing I'll point out is we talked about the artifacts. It says in this run, we've got 2 artifacts that were produced, and we can actually go down and see those artifacts. But one would be the website, and the other would be the DAC pack that was pushed up to the SQL database. And again, for the production, we deployed our production database, we deployed the website, which took that artifact from the build, and we seeded our storage account. But we did not, we shouldn't have seeded the database. Well, the job ran, but as Will, I think, pointed out earlier, we actually had a conditional operation in there which said don't actually do anything, don't actually upload the database into the data, don't upload the data into the database. And then our smoke test passed. So now we've got a work completed deployment. What we'll actually see for our test system, we have got, this is what our test system looked. This is the test data that was actually published. So these are the images that were put in the storage account, and these glitter drone 3000, that was all added via the DAC pack into the database. I know we all want a glitter drone 3000. I certainly do now. But for our production system, there are no toys, because of course, for a production system, we don't want to touch the data. We want an empty solution. So there we go. That is the end-to-end workflow. Pretty cool.
Awesome stuff.
It only took 16 minutes to deploy.
Yeah, that's relatively quick compared to some deployment times that I've interacted with the past. So yeah, it's great that we've been able to do that all in 15 minutes.
Cool. Well done. So should we jump back to the slides quickly? And we're going to do a quick knowledge check. So
yes, we are.
Quick knowledge check. We got a few minutes. Let's see if we can get through this. So which of the following statements is true? And we'll give you a few seconds, 30 seconds to answer these. A, deployment scripts run on infrastructure that's automatically managed by Azure. Deployment scripts automatically get access to your entire Azure environment. That's B. Or C, deployment scripts can't accept parameters. So go ahead and select your answer. They've got a poll there.
Yeah. Well, I certainly hope it's not B. That doesn't sound too good.
I hope our security people, of course, and everyone's a security person these days, right? Our security people are probably concerned with that one. And what about C?
I don't like the idea of deployment scripts not being able to accept parameters. That doesn't seem very flexible. So I'm going to go out on a limb here and say A.
You reckon A? You reckon A? Let's see if we are correct. Go give yourself a chocolate fish. Will, nice. That is correct. I'm sure you all got that one. So let's go to question 2. Do you want to ask this one, Will?
Yes. Okay, so we've created a workflow that's going to deploy a Cosmos DB account, a database, and a container. In our workflow's build job, we'll be compiling a small application that initializes the database with some reference data. You need to add the database initialization process to your workflow. Which of the following steps should you take? Should we A, use a separate tool like Chef or Puppet? B, create a workflow artifact for the compiled initialization application? Or C, ensure that AZ copy is installed on your runner? What do you reckon?
Well, I'm not sure Chef or Puppet's going to do. I mean, that Chef or Puppet's going to configure the virtual machine or typically used for virtual machine configuration or operating system configuration. So I'm not sure it's A. What about C?
Are you sure about that? What's your thinking behind that?
Well, I could be wrong, but yeah. Why not B? Create a workflow artifact for the compiled initialized application. I think it's B. C,
I
I
think you might be
don't see
right.
why we need to do that. So, of course, C is for AZ copy is for copying information between storage accounts or up to storage accounts. So I don't think that's the right thing here. So I'm going to go with B.
Awesome.
B it is.
I think
Go
we've
us.
got a minute to kind of wrap up, so we might have missed the
Yeah,
last question.
let's skip the last question. The answer is C, if you wanted to go along with us. But take us through the summary, Will.
So we've gone through a lot today, and we've learned a lot, which is really, really awesome. So what we've done is we've learned how to deploy our Azure infrastructure, applications, database scripts, and storage blobs all within a single workflow, rather than having separated workflows out. We've kind of unified it together to make sure they're deployed as a unit. We've used workflow scripts to publish and workflow actions to perform deployment scripts. We've used workflow artifacts to publish compiled files from our deployment workflow jobs to use. And we've also passed data from our Bicep files to other deployment steps using outputs. If you go to the next slide, we'll have, there's a link there for more information and resources. And thank you so much to everyone for joining us this morning, this evening, wherever you're watching from the world. It's been great having you join us on this journey. Make sure that you don't miss next week's session. We're going to have Chris Reddington from GitHub and Chris Ayers from my team in America. They're going to be taking us through automating Azure infrastructure change reviews by using Bicep and GitHub. Dan, it's been a pleasure hanging out with you this morning.
Will, you too?
Awesome. I might see you in the office a little bit later. But to everyone watching at home, thank you so much for joining us, and we'll see you all next time.
Thank you all. Take care.